Well, thank you, Chairman Colley, and I'm really very excited and pleased to be here and honored to be here. And I must say that I've read the report, or not every word of it, but a lot of it, and I'm extremely impressed with the Teagasc report. I just think that you're thinking at the very cutting edge of technology and food and agriculture, and will be a real contributor to the global efforts to improve sustainable agriculture. And I strongly agree with Secretary General Driscoll's concerns about the global challenges of food, energy, water, sustainability going forward, and climate change mitigation. I think he's absolutely right, and I think this report is a real contribution to that effort on a global scale, and I'll do my best to send this around Silicon Valley and other places, because I think that a lot of attention needs to be paid to it. So I want to thank Lance O'Brien and Tiernan and others at Teagasc who've brought me here and have been so terrific in dealing with and making all the arrangements. So I'm really, really pleased to be here. I'll try to keep this going here. So I wanted to really address the kind of how to think about the question of technology going forward and its changing society. One of the things that I think is we do have a lot of anti-technology thinking in the world today. And I think that there are a lot of things I'll get to later that we have to be concerned about. However, I don't think we can turn the clock back. I think technology is speeding up, as I'll discuss. And I think if you want to just think about how much impact technology has had, just think of the internet. I mean, the internet's been around basically about 20 years for us. I mean, it goes back to DARPANET in 1969, but as a global platform. And it's absolutely essential to our lives. It's integral to our personal lives, our business lives, work lives, government lives. Everything runs on the internet. It's totally transformed how we do everything. And this is just the beginning of what we're seeing forward. But I want to just stress again this point, that where there are a lot of problems with technology and things that we need to worry about and be concerned about. But I don't think we're going to get through this century well if we can't harness technology. It's not the solution, but there is no solution without the technology. It's policy, it's innovation, it's a lot of things. It's cultural, but we absolutely have to harness science and technology to get through the century. So I think one of the points I want to make is that we're seeing an exponential development of technology. It's not linear, and humans tend to think in very linear terms. They're very, and if you think of steps, linear steps, if I took 30 linear steps, about a yard long, I would get, I guess, maybe a little beyond that sign down there. If I took 30 exponential steps, the seventh step would be, the first step would be a step, the second would be 2, then 4, then 6, then 8, or rather 8, and then 16. The seventh step would be 128. The 10th step would be 1,000. The 20th step would be 1,000,000 steps. And the last step would be 1,000,000,000, 22 times around the Earth on that last step. So when you think of things at an exponential rate, it's a very different thing, and it's very hard for the human brain doesn't think in exponential terms because we don't experience the world in those terms. But that's really how things are developing. And these exponential technologies that we have, many of which are in the report, and I'll discuss a bit, are really going to change the world a lot more in the next 20 years than probably in the last 50. Some people like Ray Kurzweil think there'll be 20,000 times the change in the 21st century over all of human history from the impact of exponential technologies. We don't have to go quite that far. But I think, again, if you look at the impact of the internet or of the cell phone, it's been phenomenal in terms of our societies and how we work, what we do. So I think the other piece is that these are very disruptive changes. And as we'll discuss, and that things will not be the same in the future. We can't look out and just project, extrapolate the future. It'll be a little bit more of the present. We've already seen massive changes and just think of the companies that have come out of nowhere. The two most valuable companies in the world are Apple and Google, not General Motors or IBM or Volkswagen and they didn't even exist a matter of years ago, particularly Google, but Apple was almost bankrupt and came along. So, this is just the beginning of the kind of disruption we're going to see in how governments work and business lies, the system. But I also think that there's a great deal of potential here, as again, the Teagasc report really points to that in agriculture and food, to actually have more prosperity, have a better world, more sustainable world, maybe even a more just world going out the next 20, 30, 40, 50 years if we can really harness this. So just going back to Moore's Law, everybody's heard about Moore's Law, that every 2 years it double the power and reduce the cost of computer chips. But this is kind of applying to all these technologies as we'll go through. And I think that everything that can be digitized is subject to Moore's Law. Now, one of the things that is important to recognize here is that all this incredible technology we'll discuss, so much of it really came from government-funded research. Mariana Mazzucato has written a terrific book, The Entrepreneurial State, about this. But the 12 key technologies of the iPhone, as I always like to say, were not invented by Steve Jobs. They all came from government-funded research, most of it military, as you can see, just as an example of all this. So hundreds of billions of dollars were invested to make these technologies. But what the result has been is not only this Moore's Law increase in the capacity, computers millions of times faster, but the decrease in cost of millions of times. And this is an interesting chart that Peter Diamandis of Singularity put together in 2011, so the total would be even more right now. But if you look at all the capabilities, again, going back to my iPhone, if you have video conferencing, GPS, digital video recorder, digital cameras, music player, and then all the data access. If you tried to buy all that, of course, it'll all be separate devices, and 30 years ago, and it'd be about $900,000, probably $1 million today. Now it's free, free. That's pretty astonishing, right? So remember, that's what's happening with this Moore's Law impact on the world. Bandwidth performance. This is, don't have to look at the specifics, but you get the idea. The cost of internet connectivity has just, gone down tremendously. This is an interesting chart too, because a lot of this affects, as I'll go into, the democratization of technology, the cost of technology to get in the game has dropped. This chart was interesting because they figured if you wanted to do a startup, an internet startup in year 2000, it would cost you about $5 million in servers, software, people, all that. And now, well, that's 5 years ago. The cost, because you can use the cloud, computing, everything's dropped so much, for $5,000. So you get 10 friends together, give you $500 a piece, and you've got a company. I mean, it's astonishing. People are starting companies. A friend that teaches bioengineering at Stanford told me kids, pull together $10,000 and they've got companies in their dorm rooms, biotech startups. That's in biotech. Maybe. So you have this amazing drop in cost. This is absolutely critical because it means it's leveling the global playing field. So these technologies too, you have to see them as really converging and enabling each other. And as I said, everything that can be digitized will be digitized. And one of the things to remember about when things are digitized is that there's zero marginal cost of the next product. For example, if you have a book, you write a book and you publish a book, the more copies you sell of that book as a physical book, the cheaper they get per copy, right? They go down, but they never get close to zero, right? You still have to have the paper and you have to print it and you have to ship it, you have to market it. But the zero marginal cost of the next digital download on a Kindle book is zero. It doesn't cost anything, right? So as you digitize things, you change this whole dynamic toward zero marginal cost of the next product. And also, if you only had one book available and there's two of us want the book, then you got scarcity, right? One of us gets the book, and maybe you bid to see who pays the most for it. But if it's digital, there's no scarcity. Everybody can have that book. Everybody can download it, right? There's no limit to the copies can be made when things are digitized. Now you see that in the music industry. You see it in a lot of places. It's had a big impact. And then the point here is that all these different technologies are mutually enabling. Again, if you go back to the smartphone, it's all these, the GPS, the internet, big data, cloud computing, storage, internet of things. All these things are what makes this smartphone a smartphone. It's the bringing together of the technologies. It's not one separate technology. And the same thing with robotics and self-driving cars based on cheap sensors and all these things. We'll go into that a little bit more. 3D printing, again, is another technology that's really digitizing the material world and then rematerializing it. And, you know, again, it's enabled by all these other technologies. And now in genomics, as mentioned, you know, we now can, on a computer, you can just digitize DNA and design you know, a virus or any other kind of life form. So we'll go into that more. But I want to just make the point here that these are all platforms. And you have to think of the internet itself as the platform of platforms. I mean, it's just out there. Everybody can use the internet for whatever. And you can, and nobody in 1993, when the web went live, I'm sure nobody even thought of something like a Google or Facebook or Twitter, or all these things that function on the internet itself. So the internet is like the key platform of all platforms in the digital world. And I think that's one of the key things is spreading that platform to bring that to everybody on the planet, broadband, high-speed internet. So then you look at social media. I mean, Facebook then is a platform on the platform. Facebook is used, particularly in the developing world, as a very important economic tool for selling, et cetera. Then Twitter, all these different things are just, again, platforms. The cloud computing and storage is another platform for you to do experiments in the biological field and building a business. Everybody is now using these massive cloud computing systems built on, you know, thousands or millions of servers and server farms at Amazon Web Services and Google and IBM. And again, those are platforms for you to do whatever you want to do with them. And again, artificial intelligence now has been developed at great expense and all. It's been Google's DeepMind and of course Watson we'll get into and everything. But that's a platform for people to use. People are using those to build new apps and new applications. They're another platform. In the smartphone apps, I mean, I was really surprised to learn recently that Steve Jobs was actually not excited about letting the system be open to anybody. So the idea of apps was really not in the original iPhone. And they finally said, okay, we'll let them do it. And the App Store opened, I think, in 2008 with 552 apps. And now they're about 2 million. And nobody could envision what those would be, what they'd be used for. I mean, just amazing variety of things. Again, the app is another platform for people to build on and use it for whatever purpose they might have in mind. And the Internet of Things, now we're going to have ultimately trillions of sensors. And it's another platform for doing whatever it is you want to do. We're going to have the Internet of Farm Things, which is going to be phenomenal. And 3D printing, again, is another platform for people to design, build things, make things. So these things are all, and of course drones now, we'll see that. They come down in price to the point anybody can have a drone if they want to use it for all kinds of purposes. We're just beginning to see what those purposes might be, just as we are with 3D printing. And again, with computational biology. So I just want to go into a few of these areas, you know, big data. I love these word clouds because they're sort of like, I mean, they're kind of crazy, but you can see all the different aspects, things that relate to big data. And this Internet of Farm Things runs on massive big data. Big data is really the, I mean, here, I love these charts. You know, they don't really, hard to grasp, but when you think of an exabyte, I was just reading an exabyte, which is 1 billion gigabytes, is equivalent, 1 exabyte would be the amount of number of words spoken by all human beings in history would add up to about an exabyte. So it's a lot of data, a whole lot of data. And now we're generating zettabytes, which is 1,000 exabytes, right? That's how much goes over the internet every year, about 1.3 zettabytes. And we're going to get 40 zettabytes a year, you know, accumulating by 2020. It's just massive amounts of data. And of course, doing something with it is what really matters, right? And it's made possible by the internet because that's how you move it around. And it's just a million-fold decrease in the cost of storage. Storage and computational power is close to free now. And of course, with your iPhone, you're accessing the cloud and using it all the time, and you're not paying for it, right? Except for the, you know, access to the internet and the phone itself. So all this stuff is made possible by the big data analytics, the algorithms to make sense of this data. And believe me, all that data is not all being used in any effective way, and a lot of it's just exhaust and will be thrown out. But this massive amount being created. And then the Internet of Things, as we get into, is you have a trillion sensors. That's a lot of data being generated at a time. And again, big data is all behind figuring out what to do with it. But it's becoming crucial to have this, you know, you don't have when you're looking for needles in the haystack, you just get the entire haystack and analyze it. And so it's, and very quickly. So this advances in science and technology and climate change and computational biology and every area is being advanced by this data that we're accumulating, which really is massive. And a Google car, for example, creates a gigabyte of data per second. So think of, you know, if you had a million Google cars, just think of the amount of data being created by all those cars, and they're constantly in you know, touch with, through the internet, with the cloud, using the processing and learning. And that's the other thing about this massive amount of data. It's a matter of learning with it. So, and of course, as raised earlier, we have concern about data being accumulated about us. Our digital exhaust, as it were, as we travel the internet, we go on Twitter and Facebook and everything else, or buy stuff online. There's all this data being collected about us, and of great concern to privacy issues. And those are going to, you know, be something we're worried about for quite a while. But we're going to also see this big data being used to really transform how we do things. This is just an IBM chart about big data and insights in running cities and water management. And we've seen in agriculture, and the Teagasc report again shows a massive improvements possible with the effective use of big data that will be collected from sensors on cows, on the barns, on the tractors, in the soil. Massive amounts of data that will be used to improve efficiency, better understand what's being done, and a massive amount of data on us, on our biomes, on our genetics, on all the things to personalize medicine about us. So turning it into something insightful is going to be the challenge. And then we're going to have this massive increase in the Internet of Things. Right now, there's a lot of debate. I mean, you have two types of things. One is actual device. This is, again, a device that's connected to the Internet. So the Internet of Things includes all your iPhones and smartphones, et cetera, et cetera. But it also may include sensors that are not that are on the cow, that are on the car, that are on they're going to be everywhere. So that right now we have maybe 15 billion things connected to the internet. We're headed to 50 billion, but I think in the 2020s they're talking about trillions of things. I work with little companies doing nano RFIDs, which by the billions, size of a blood cell. If you had nano RFIDs and all, I mean, the amount of data being connected to the Internet of Things, and these things are going to be communicating with each other, with you, and the data being processed, made to help make decisions, to understand what you're dealing with. This is just going to be ubiquitous everywhere. Buildings will have, you know, sensors all over them that can be used for various purposes and being analyzed. So this is just the way we're going. And here's, interestingly enough, this is another, I think it was an IBM diagram. There's not a lot on the farm here in this set of all the different Internet of Things that they're missing. There's a big hole here. But this is, everything is going to be wired up. You're going to walk in an environment where you have all this information around you that can be tapped and made sense of and be used to make intelligent decisions, one hopes. So the whole question of artificial intelligence, which of course, again, as I said, really recently we have this whole debate with, you know, here's Watson, the IBM computer, with Elon Musk and Stephen Hawking warning that, you know, that artificial intelligence is going to be the end of us all. Or as a friend of mine and is a futurist in Silicon Valley always talks about, he says, that, you know, the question is going to be whether we're pets or food to the artificially intelligent robots as they dominate the world. I think we're a very, very, very far away from a generalized self-conscious artificial intelligence. But what we are getting is far more ability to understand our environment, machines that can understand human speech. We're not far from the Star Trek translator, where you can have real-time translation talking to somebody in a different language. And we have image recognition on the internet. All this from these deep learning, new ways that artificial intelligence actually, after decades of kind of stalling and hope that never was fulfilled, seems to really be taking off. But these are tools. I mean, Watson, if you may remember, is the IBM computer system that won Jeopardy, the game show in the United States, which was very, very difficult. I had to understand spoken language and then understand what the question or the answer meant and then find the question to the answer and beat the best humans. It was pretty phenomenal. It was about 5 years ago. But Watson's now being used as an assistant to a doctor. And if you think about you go to your doctor and you want her to know all the literature on all the symptoms you have and all the possible treatments, which is millions and millions of pages, which she could never possibly read, right? But if you have an assistant that can instantly access all that, take your symptoms and say, well, the probabilities of various different symptoms mean certain diagnosis or, this and this and this, and the treatments have been done on this and this and this for this kind of a problem, to advise your doctor, I personally would feel much more confident that that doctor now has access to basically the world's knowledge and experience dealing with my symptoms and what should be done about them. And this is now happening in oncology, and they're turning this into a product, but it's going to advise people in all kinds of fields. So artificial intelligence is going to be just another tool so we can do our job better, understand whatever the issue is we're dealing with, the ramifications, get advice, but it doesn't mean we're taken out of the loop and artificial intelligence is going to run our lives. So I think this is, my line, and particularly after Secretary General O'Driscoll's shared concern about global challenges, I think we need all the intelligence we can get. And I'm coming from a country at this moment, when you look at our political system, you wonder how much intelligence we have. That's a very big question mark. Anyway, back to the question of robotics, and this is getting really fascinating because we grew up with robots were these big machines in cages in factories building Audis, right, with cheat systems in them. No, excuse me, I didn't say that. And Volkswagens. No, but that's where our image of what the robots were, other than the fantasy robots that, Terminator or something's going to take over the world. But now the robots are really coming out of the cage. Does I have a little pointer here? Whoops, I didn't mean to do that. I think I just screwed up here. No. But on the right there, you see the Baxter, which is a $22,000 robot that you can work with. You can program. You grab the arms and show it what it needs to do, and it does it, and you work alongside it. It can't hurt a human being. It could help move stuff, do different things you want to do. Hubo won the DARPA challenge for a robot that could drive a car, get out of a car, go up steps, open a door, crash through a wall, and turn off a valve like a nuclear reactor, for example. Do all those things. Those are really difficult things. One thing to remember about computers, the things that are really hard for us are really easy for computers. The things that are really easy for us are really hard for computers, like walking, like grabbing something, like all the things we do without even thinking about it are extremely difficult for computers to do, or robotic run computers. But we're coming out. In the middle there, this beam computer is very cool. It's going to take over, be a lot of office. That is like an iPad on the top of a little mobile device that you can remotely run. And I've seen these in operation at Willow Garage, where a person is in their home, let's say it could be somewhere in the UK, and they're working in a company in Dublin, and they have this that they can make it go wander all over the office in Dublin and talk to people, and even ask people to open the door for them. And be part of a conversation, just move around, and you can talk back and forth with it. It sees where it's going. This kind of thing for sort of remote telepresence. This is another kind of robot. And then, of course, you've heard about the Amazon now with delivering packages with robots. Interestingly enough, so much of this stuff comes from startups. It doesn't come from the big companies. And there's Singularity University that I'm involved with has this graduate studies program, and they have these students come up with an idea to change the lives of 1 billion people over 10 years. And one of them was a company called Matternet about 5 years ago. And their idea was to use these autonomous drones to deliver high-value, like medicines in rural areas in Africa, especially where there are no roads, or the roads washed out. You could send medicines or high-value packages to these places, and then the drone would come back, and the drones would cost $200 or $300 because of what's happened in the price of technology. Now Amazon's using it for delivery. And actually, Matternet's working with Swiss mail service to deliver mail, I guess, in probably particularly difficult to get to areas. But all this is happening. And on the right, of course, is the Google self-driving car, one of the little ones that doesn't even have a steering wheel in it. But the self-driving, they're all robots, are all being powered by all these convergence of technology. It's just a robot I saw at Singularity. It's, I don't know, maybe 150, 200 bucks. Now you get these things, you put a camera on it, use it for whatever purpose you want to use it. These are just, I think there were 2.5 million of these things sold last year. So this is all taken off. And then one of the areas that I find most been involved with and I find most amazing is 3D printing. I assume most of you are familiar with 3D printing, but the basic idea is you build things by layers up instead of taking a piece of metal and carving out what you want from it. You build something by layering it. Think of the easy way to think of a 3D printer is think of an inkjet printer. That, you know, you have a piece of paper and you print on it and then the paper comes out. Well, supposing you had the printer and you had, let's say, 4 or 5 colors and you print on it, but then you drop it down and print another layer on it. Then you drop it down and print another layer. Pretty soon you build a 3-dimensional structure. That's basically the idea of what 3D printing does. So what's happened is this 3D printing, which used to be extremely expensive, is now very, very cheap. You can buy 3D printers for a few $100s. Obviously, they vary in their capabilities. But what's happened is so much of this has come from startups. On the left here, this is a 3D printer, the first one built in Brazil, first 3D printer maker in Brazil. I visited this guy at calls it the Cleaver in Porto Alegre a couple of years ago. And there are all these tech shops where you can go and you have access to 3D printers and laser cutters to do whatever you want to do, but maybe build a company around the idea of what you can print out. Even printing out buildings, and this is going to be a very big issue going forward, that we can print construction. And if you can print a building, let's say a 4 or 5 story building, you could probably do it in a matter of weeks rather than years or many, many months. You can reduce the cost by perhaps up to 80%. You use recycled concrete and there's virtually no waste. And every time you build, it can be different. That's one of the amazing things about 3D printing is that complexity is free. There's no more difficulty in print things like this. You can't make that any other way than print it. You can't make a structure like that, but you can print anything you want, anything you could conceive of, you can print. And so and every time you print, it can be different. And every printer could be a factory that never has to be retooled. Anything that was in the parameters of the materials being used by that printer and the size and resolution, every time it prints an entirely different product. No factory assembly lines and stuff. So, you know, there's a really interesting things going on. And one of the things that really strikes me is, again, it goes back to this democratization of technology and making it cheap. It's very interesting that this little company, Made in Space, which started again at Singularity in 2010, 3 guys said, you can't go into space. We need to go into space to develop it for humanity. You can't go into space if you can't make stuff in space. It's too expensive and difficult to haul everything out of the gravity well of Earth. And so they said, well, the only way you can make stuff in space is with a 3D printer. You've got to print stuff in space, right? So they worked with NASA and developed the first 3D printer that could print in a zero gravity, which is now on the space station. It's been there about 1.5 years. And they're building a commercial one, this gray one, it's going up any time right now. And they have also developed and are now got a contract with NASA and Northrop to make giant arrays in space. They've developed a printer that can print in the vacuum of space. So you just hang it off the space station or out in orbit and robotic arms, and you can print giant arrays. You can print, you know, solar arrays, antennas. Ultimately, they want to print the next space station and print habitats on the moon and Mars. So when the astronauts get there, the hotel will be ready, and a robotic concierge, no doubt. But I mean, this is transforming, and what's amazing, this is space. This is the most difficult area. And here again, this little company, I always find it very interesting. It wasn't Lockheed or Boeing that built the first 3D printer on space station. It was a little company of 3 guys, who now is 22 people, and it would cost about $2 or $3 million. For Lockheed to do it would probably be 50 to 100 million, and there's no money in it. They like markets, big markets, where they can make lots of money, and the printer on the space station is going to make a lot of money for made in space. But here's the other area that's incredibly disruptive. Again, it shows these technologies. This CubeSat. These little satellites are 10 centimeters cubed, and the guts of it are basically an Android phone. And they cost maybe $100,000 to make. And they're now being made, well, there are about 100 of them been put up by a company called Planet Labs, which is some people from, started a company that used to be at NASA. And they can be used by, they're cheap enough that a university or research, or they're going to get even cheaper, can be used by Teagasc and to monitor soil, monitor pollution, hyperspectral analysis. There's a company that's building a network that's going to give real-time video downloads to 1 meter resolution of the whole planet. Again, these are startup companies. These things are, a few $100,000. And now they're working with Made in Space. They've got a contract. They'll actually build these things on the space station and throw them out the window. So you need a satellite, for an urgently need a satellite to monitor something, pollution or a forest fire or something. They could actually assemble it on the space station. They'll have some of the guts there and design it, print it out, and have a little launcher on the space station, throw it out. And again, these are a little startup. This is totally disrupting the satellite industry. Lockheed likes to make these billion-dollar satellites. They take 5 years to design, another 5 years by the time they're up, and they're going to last, hopefully a long time, and they're out of date by the time they ever go up, right, in technology. These things are updated every few months, new technology. So, and I know little companies that are starting a hyperspectral analysis startup for these things. There are going to be thousands of them, and some of them will be used to enhance connectivity. So here's the next one, and wave is really in synthetic biology and genomics. There's an organization called BioBricks, which it's co-founded by a friend of mine, Drew Endy from Stanford. And they have, I guess, tens of thousands now of basically, if you think of software modules, let's suppose you're building a software program and you want a drop-down menu. Well, you don't want to have to write the code for a drop-down menu. You go and pull out a drop-down menu module and pop it into your software program, right? Well, now you're going to be able to build an organism. And you don't know how you pull out the pieces of the organism and the different functions and download the software, put it together, and you've got an organism, the BioBricks. And it's astonishing what's being done now in biology. And again, it's a real function of all what happened with genomics. The cost of, we see the cost of genome sequencing went from, well, it was $3 billion for the first human genome sequencing, and now it's down to $1,000. Maybe it'll go to a couple hundred. Eventually, it'll just be a standard thing. Everybody gets sequenced. And then you can find out all about your genome and what your vulnerabilities might be. So I think that's a really big change. And you see this with CRISPR technology now for gene editing, which, by the way, is the US FDA does not consider gene editing with CRISPR to be GMOs. So it's not regulated. It's an interesting question because I know GMOs are kind of, people are rather, there's a rather anti-scientific attitudes towards GMOs in the United States. And that the question that I visited this wonderful company, Organovo, which is using 3D printing, bioprinters to print human tissue at the moment, and will eventually be able to print a human organ. So if you need a replacement liver or a kidney or whatever, they could use your own cells to build you a new organ, print it out, and then you wouldn't have to wait for transplant. There would be no rejection because it would be your own cells. This is where they're getting to, and there are a number of companies, or again, startups or university researchers that are making huge progress on bioprinting tissues, replacement. Right now, for example, they can print out, I'm going to be visiting these guys next week, so I'll find out where they are, because when I did 2 years ago, they were already at the point that they could have like 20 cell thick liver tissue samples, the real liver tissue, so you could use those for toxicity testing rather than, and short circuit all the long process of testing on animals, because almost all drugs have to have liver toxicity testing before they're approved. So you could really make much cheaper and faster the development of new drugs through using these tissues. But there's going to be this whole ability to replace almost all your body parts. Maybe not, the brain will be a hard one. And then again, BioCurious, I just had that up there because these little hacker spaces, just like hacker spaces for working with software or working with 3D printing. I visited BioCurious, and there's just these people interested in finding a new strain of wheat, for example, that's heat resistant to climate change. And they're working on this stuff. And because again, this technology is so cheap and available. CRISPR you can do in your kitchen for gene editing. I mean, just absolutely astonishing. So one of the things that I find very interesting is that we don't know how many startups there are. There are probably millions. Like I said, I went to Porto Alegre and Florianópolis, Brazil. I gave talks in those places I had not heard of until I was invited to speak there. I mean, if you're Brazilian, you know these places, but I didn't know them. But there were hundreds of startups in these little cities. A lot of them working, using internet startups, building apps, doing all kinds of stuff for 3D printing. And this is going on everywhere, and even in Silicon Valley. Nobody has any idea of how much is actually going on because it's no longer confined to research institutes at universities or to the national laboratories or big corporations. Anybody could be coming up with a new business around these technologies. It's a completely different world, and it's very hard to assess and know what's totally going on, but it's a lot. So I just want to say a couple last things here, but just in thinking about exponential technologies, you sort of have to think of in different orders of impact. First, of course, is just the technology and invention. But unless it's used, it's not really important. So the how the technology is used is really critical. And then what kind of impact it has on society, and then how these various technologies interact with each other. That's what you want to try to understand as you look forward. And of course, very difficult to really project, particularly you get further out. The first order, you can see what inventions are on the horizon, how they're going to be used. I think, again, I go back to the smartphone, and I don't think anybody foresaw how fast and how extraordinary what the capabilities would be so quickly, and how they would affect society, everybody. We've got, Janet was telling an example here of being in sub-Saharan Africa with a peasant who was a farmer who was illiterate, who had a smartphone that could read sensors in the ground, and little pictures would tell the person on the smartphone whether they need more fertilizer or water or whatever. For an illiterate person to use the technology to improve agriculture. I mean, who would have thought? But that's what's happening. So you have to kind of look at it in those terms. So some of the impacts you see, again, of drones, self-driving cars is going to lead to, for example, redesigning urban spaces. Right now, cars are used about 5 to 8% of the time that you have a car. The rest of the times it's in garages, it's parked, it's not being used, it's a wasted asset, really. And we design cities around cars. I grew up near Los Angeles, right? I mean, it's just one big set of freeways, and everything's around the car. 60% of, I guess, average of cities is devoted to the car, streets and parking lots, et cetera. But what if you had self-driving cars that you access like an Uber? So you didn't even bother to own a car. You just call it up within 30 seconds. You've got a car. It takes you where to go and leads you off and picks somebody else up. It really never has to be parked. It doesn't have to be maybe serviced, but it's kind of being used all the time. And you don't need to build your city around cars. So if you're thinking out 20 or 30 or 40, and cities are built for hundreds of years, really. Are you going to build your infrastructure assuming it's more and more Los Angeles? Just more cars, more cars. We need more freeways, more. Maybe not. Maybe we're going to redesign our cities to really fit the capabilities that we're now building. And this is all true with smart cities. You have this, of course, the sharing economy, which has been very huge impact with, from starting with eBay and all the ways that people now can share resources and have much more impact on even on governance. This kind of area, blockchain, I don't want to really get into, but this is Bitcoin and all, but it's going to have a really big impact on banking and other areas where third-party trust is so important, because with the blockchain, you can't have fraud, you can't have duplication. The record is there on every computer. It's not held by one particularly corruptible place. Now, 3D printing, I think, is just going to, really astonishing potential impact because it eliminates supply chains. I mean, ultimately, you should be able to print the iPhone instead of making, thousands and thousands of parts that converge on a factory in China through all these supply chains and then are assembled there, and they, send millions of these around the world, and then you go buy them at your store. You should be able to print these out. It may be another 10 years before that's possible. It won't be an iPhone 15 or whatever. But I mean, more and more stuff can be printed at the point of consumption. So your supply chains could really diminish. I would not want to invest in shipping lines because ultimately I think you'll have peak globalization. The amount of stuff we move around the world will start to peak and decline as we move off of fossil fuels, stop moving as much liquid fuels and coal around the world, and products that it can be 90% of the products on a container ship ultimately could probably be printed at the point of consumption. So why move that? That's going to be very disruptive to global trade, to the people that in the supply chains that produce the parts that no longer need to be produced separately. So 3D printing is going to be potentially extremely disruptive, but it also brings manufacturing home, and that's happening in the United States. 3D printing and other advanced manufacturing is having a very big impact on manufacturing in the United States, the return of it. And again, it's customization. Every time you print can be unique. So you print more and more to fit the need of the customer. Rather than fitting the customer to the product, you put the product to the customer. And the customer can actually design the product and order it. We have places like Shapeways that print stuff out for you. So you're going to, there'll be a real change here of what goes on, and it could be far more sustainable because there's no waste in 3D printing. That's one of the things, almost no waste at all. Because like, for example, if you make a titanium landing gear right now, you chop it out of a big block of titanium, and 95% of that titanium is lost. It's mixed with chemicals. It's waste. If you print one, you print it with powder, and you don't have any waste. You just use whatever you use to make the item itself. And this is true for all the 3D printing. So the amount of waste is greatly diminished, and you only make something when you want it. You don't have inventory. You produce it when you need it. So the impact on the environment could be rather profound, as well as on the actual qualities of products. So one other point here, is we've talked about exponential organizations. A friend of mine, Salim, need to wind this up. I'm almost done. But exponential organizations that leverage technologies like Airbnb, which is the largest, almost the largest hotelier in the world and doesn't own a single room. And it's run by about 1,300 people, and it's valued, I think, $8 billion, $10 billion. It's bigger than Hyatt. Uber, which is the biggest taxi company in the world and doesn't own a single vehicle, right? It's just an app company. Well, these things are really, these kinds of organizations are upsetting the whole environment. So, and the last point on this would just be that, we can move from a world of scarcity to a world of abundance, potentially, if we marshal these technologies. I think we can have a discussion later maybe about job destruction. Clearly, these new technologies are going to destroy a lot of job categories, but on the other hand, create new categories. And working with computers and robots is going to be very, very critical for one's future is to be employed. But this is a big issue, a lot of different ideas. And I'll just end with these last few comments here. I love this quote. It's a Chinese proverb that Mao Zedong liked for other reasons. The tree prefers calm, but the wind will not subside. We would like to have stability, predictability in the world, everything. We kind of know where it's going to be. That isn't going to happen, so forget it. The tree would like it to be calm, but the wind's going to keep blowing, so just live with it. So we're going to see this exponential acceleration of technology continuing. It's going to be disruptive, and it's probably going to accelerate, as I said. We're going to see these democratized technologies actually level the global playing field, including the small farmer is going to have access to the kind of technology that the big farmer only had in the past. And there aren't too many big farmers in Ireland, I understand. It's really America where you get these big farms that could pay for these $1-million machines, et cetera. That's all changing, from drones to artificial intelligence to all the capabilities, Internet of Farm things. This is all going to be cheap. Anybody can get in the game. So this is a very different world. And it's, like I said, there's new dangers and threats, but I don't think we can meet the global grand challenges without it. And I think we have a potentially better future. It's not just doing less. We don't have to have an Eeyore world, where, oh, it's going to rain and we got to hunker down, it's going to be worse. I think we could make it actually a much better world, more prosperous for more people, a more just and secure world. So thank you very much. And here's a reading list.